So we're now going to look at order Cetacea. This is the order that includes whales, dolphins, and porpoises in it. And within that, we're also going to take a look at some physiological adaptations that these animals have to living in water, especially cold water. And some of these adaptations we're going to see also with pinnipeds, with seals and sea lions and walruses. So something about cetaceans that's important, like the other marine mammals you've studied so far, they evolved from a land ancestor. That's what fossil evidence shows us. And so, therefore, they breathe air. They have a vestigial hip bone. They're mammals, truly, so they nurse their babies. And they also, all of them, have a little bit of hair on their body, even whales and dolphins, which is kind of interesting. So the vestigial pelvis is a big thing. They have a hip bone. It's vestigial, referring to any adaptation or trait that is no longer useful, but it's still there. It's something that the organism still develops as it grows, even though the use for it has gone away. So we have a few vestigial parts. Our tailbone is the biggest one. We have a vestigial tailbone that's a remnant of our ancestors. And whales and dolphins and porpoises all have a vestigial hip bone. What's interesting too is that their front appendages, so their foreflippers or their pectoral fins, all have the same bone structure as all other mammals, which is a five-fingered or five-phalangeed structure. And so that's another adaptation that we see consistent with all other mammals too. So other main characteristics of cetaceans, they all breathe through a hole in the top of their head called a blowhole. And so you see them surfacing and you see water spout out through the top, and that's their blowhole releasing air. That's them exhaling carbon dioxide. And oftentimes there's water that's just gathered around the blowhole, and that's what you see spraying up. Very streamlined bodies with skin, thick layer of blubber underneath. The thickness varies from species to species. Some of them have a little thicker depending on where they live. They have no neck, so their head is continuous with the rest of their vertebrae. No external ears, so they only have a small internal hole. It's plugged usually with wax, and so that's how they're able to keep water out of their ear. The tiny hairs that they have are on the tip of their snout or the top of their head. So next time you're up close to a whale or a dolphin, if you happen to be, you can take a look, and some of them do have a little bit of peach fuzz on the tip of their snout. Whales and dolphins also have no sweat glands, and so that's an adaptation for retaining fresh water. They do not sweat. They are capable of pooling blood in their blubber to conserve heat. So that's another adaptation we're going to look at that's very important for them to be able to live in the water without getting hypothermia like we would. They also have flat tail flukes that they use for a variety of things, propulsion, defense, communication. And that dense tissue in there also gives them a little bit of ability to conserve heat, because the blood does not spread out through the tail flukes very easily, and so it conserves the blood. The blood stays more towards the core of the body, and that helps to retain heat as well. And the big characteristic they have with heat retention is called countercurrent flow. And what that basically means is that you've got veins and arteries passing next to each other, so that if you've got, for example, an artery which is containing very warm blood that's coming from the core of the body and going outward into the extremities, that warm blood is going to pass through the artery. Now, if you have the veins wrapped around it, then there's an opportunity for heat exchange, for some of the heat from that warm arterial blood to diffuse into the cooler blood that's in the veins. And the veins contains the blood that's coming from the outer part of the body, so the veins coming from the extremities that are cooler. And I'm going to move the screen over just a little bit so you can see another diagram of the same thing, only it's color-coded, so it's a little easier to understand. You have the warm blood in red and the cool blood in blue, and the heat is going to diffuse across it so that the warmth is spread out throughout the blood, so that the body's getting more heat spread throughout the cardiovascular system. So that's a really important adaptation, that countercurrent flow. And there's just an image of that vestigial pelvis. This is in a bowhead whale. So some diving adaptations that's important. So a lot of whales and dolphins and porpoises dive really deep to eat and hunt. And so to do that, they have some really interesting adaptations. They have relatively small lungs for their body size. So if we were to compare them to land mammals, say an elephant, the elephant has much significantly larger lungs to be able to get as much oxygen as it can into its body, which is needing more oxygen than a smaller animal. But these guys have relatively small lungs, but they make up for it with a higher amount of blood and oxygen exchange. So even though they're not getting in as much oxygen, they are able to maximize the amount of oxygen they are getting through a higher exchange in the bloodstream. Typically, they dive with full lungs, and they can adjust their buoyancy that way. So as they're trying to sink down deeper into the water, they might expel some air out of their blowhole and help collapse their lungs so that they can become more dense and sink. And something that also does is that as they collapse their lungs, their rib cages are actually adapted to help this happen. The rib cages will push against the lungs, help to push air out of the lungs, and it forces the air into the respiratory pathways. So it forces the air out of the lungs and into the bloodstream. And so that way there's no gas exchange taking place, and it saves air. So they're able to hold on to oxygen longer before carbon dioxide is exchanged for it. And that's kind of a nice little trick. That also helps them avoid getting the bends. And so if you're not familiar with what the bends is, if you're a scuba diver, you should know about it. Basically, it's what happens when you have air bubbles that are inside your bloodstream. And due to Boyle's law, if you remember physics, when you have a pocket of air that's in a high pressure situation, so deep underwater where there's very high water pressure, and you take that bubble of air and you bring it up into lower pressure, it's going to expand. And so that expansion can cause severe sickness or death. So whales and dolphins and porpoises, as well as sea lions and seals, avoid this, partially because they're able to collapse their ribs and force the gas into the airways, into the respiratory pathways. They're also able to slow their metabolism while they're diving, and this is actually going to be the lab that you do this week with a partner or with somebody at home who can help you. You're going to do a bradycardia lab where you try to slow your own metabolism by inducing a dive reflex. So basically, as soon as your body senses that you're underwater, it senses that you're wet and that you're holding your breath, your metabolism immediately slows down and your heart rate will drop. And that's the purpose of that, is to conserve the amount of oxygen that your body's using up. So it's pretty cool. With these marine mammals, their heart rate can slow down to as slow as 10% of normal, which is pretty amazing. They also have twice as much blood per body weight. So blood is, of course, useful for the transport of all kinds of substances, but in their case, it's especially useful for transporting oxygen. So another dive adaptation is they have a lot more blood than we do, or than other mammals. They also have a high amount of myoglobin in their muscles. Myoglobin is a transport protein that helps to hold on to oxygen so that the muscles can use it. And so this, again, allows them to function and allows their muscles to work even though they're they're diving in extreme pressure and very cold temperatures. They're able to still function. Something else that they do, they can actually blow bubbles of nitrogen out of their blowhole to, again, help to avoid the bends. So that's another thing. And another thing about marine mammals is that their voice box does not open in the throat, it opens in the nasal chambers. So anytime you see a video of a dolphin opening its mouth and making that squeaking noise, it's kind of a farce. They make the dolphin do that because it looks more human-like, but the dolphin's noises are all coming out of the blowhole, every single one of them. They have nothing coming out of their throat, out of their voice box. So some important behaviors of cetaceans, we'll just go through these pictures real quick. Some of these might look familiar. They're known for spy hopping, which is where they pop their head up straight out of the water. Purpose of that is to look around and see what's going on at the surface. Breaching is a common one, and there's a lot of reasons for breaching. Could be communication, it could be to establish dominance, it could just be play and joy. They do tend to play a lot. In some cases, they think it could be to scratch their skin. A lot of animals in the water tend to have barnacles that live on them. And so in the case of this humpback whale here, he might be breaching to knock some of those barnacles off of his skin. Fin slapping is another one. There's several ways that this happens. They can slap it straight down. They can slap it to the side, slashing their fin back and forth. Their tail flukes are a very important tool for communication between whales and to signal distress or to signal irritation. Pectoral stroking, oftentimes cetaceans will stroke up against each other with their pectoral fins, and that could be a bonding behavior, usually not a sign of aggression. Lots and lots of species of whales and dolphins. This diagram just shows a few, but what's interesting is here on the left side, you can't really see it very well, but it shows some size comparisons. The blue whale is, of course, the largest animal on Earth and the largest member of cetaceans, obviously. Um, some of the larger toothed whales include the sperm whale. That's this guy right here, also known as Moby Dick, or seen in the Moby Dick novel, if you've ever read it. And then smaller cetaceans are going to be the dolphins and porpoises. And so these guys are much smaller, sometimes as long as a human, sometimes even smaller than that. So a huge size range among cetaceans. As far as reproduction goes, they're all mammals again, so babies will nurse off of mom. Mating occurs in water as well as birth, so they give birth in water. As soon as that baby comes out, the baby makes a beeline for the surface to take its first breath. In some, the details of their reproduction is a little bit specific to different groups of whales. Baleen whales, which are humpback whales, blue whales, fin whales, these guys mate and give birth at the same location in the same time of year. So they go to the same place to give birth each time. Toothed whales, so that would be like the sperm whale, or dolphins and porpoises, or toothed whales. These guys breed continuously, so they could breed at any time throughout the year. Gestation can be 10 to 13 months for a baleen whale, and anywhere from 7 to 17 months for a toothed whale. The range is pretty high there, because again, with toothed whales, we can have smaller animals like the little river dolphins and porpoises, or the largest dolphin is the killer whale, and they have a gestation of, I believe, around 16 months, but I gotta double check that. Usually they only have one baby at a time, and so they'll have, and twins can happen, but it's fairly rare. Usually they can only support one at a time. Babies nurse on mom for pretty long time, pretty high calorie milk. They get a lot of nutrition that way, and then the parents teach them how to fish, teach them how to hunt on their own. Now, as far as their social behavior, baleen whales tend to be solitary. They don't really form pods most of the time, whereas toothed whales tend to stay in pods or families. And so, again, that's going to be sperm whales, the pilot whales, dolphins, and porpoises. They also can take in the job of raising the babies together. So it takes a village or it takes a pod. So we'll look at the baleen whales first. They're part of the suborder Mysticeti. And these guys, the term baleen refers to their what they have instead of teeth. They don't have true teeth. They have these brush-like plates called baleen, and they use it for filtering food. So these are the largest of the cetaceans, the baleen whales, blue whales, humpback whales, bowhead whales, fin whales, sei whales, and they filter feed on krill and plankton. So these large animals actually eat very, very small animals. Larger whales can get up to 10 tons of krill during one feeding. So it's incredible how much food they can get by doing this. Sometimes they make a bubble net, so they blow a net of bubbles in a ring to kind of stun or trap their prey. A lot of the time they eat fish as well, honestly. The humpback whales tend to get a lot of fish in when they try to feed on krill and plankton. So I'll just go through some of them here. The right whale and the bowhead whale, these guys were hunted extremely extensively. In fact, the name right whale was given because it was the correct whale for hunting. They're very rare now, and thankfully they're protected due to the Marine Mammal Protection Act, but they're on the decline. They're not doing so well. These guys are found in North Atlantic waters and in Antarctica. So you find them in this range here, as you see on the map. Rorquals. Rorqual is a term for the whales that have the giant grooves on their chin. So these are the ones that are able to puff out that big chin and open up their mouth, swallow in a ton of water, and then strain it back through their baleen to get the krill and plankton from within it. So these guys can be much faster than the bowhead or right whale. They can travel for very, very long distances. They tend to be pretty migratory. The blue whale is the largest, up to 100 feet long and 100 tons. The fin whale, second largest, looks very similar to the blue whale in a lot of ways, but they have some different patterns and markings. The humpback is very well known. There's 3 different populations, the North Atlantic, the North Pacific, and the Southern Hemisphere. So they've got different pectoral fin patterns to distinguish them. These guys are all migratory, so they do move quite a bit throughout the oceans. Their complex songs are very well known, how they vocalize. And then finally, there's the gray whales. They used to be very common in the Pacific and Atlantic, but now only the East Pacific species are found. So you'll find these guys along California and Mexico.